Or is so I don't have any questions pending kecuali chapter 1 yang some of you requested to discuss. We can do that after we finish the chapter, okay? On chapter 1. And then if you have questions on chapter 2, boleh bagi tahu juga, okay? Okay, so let's do a little recap as usual. Recap time. So we know that if we have like an upward motion and then a downward motion, then I will have a V equals to 0 over here because when I launch my ball, right? When I launch my ball, I start with V naught, which can be broken down or resolved into its components ux and uy. So v naught is initial velocity, or in other words, it's called u. So I resolve this launching angle that they gave me, and I resolve it into ux and uy. And ux is v naught cosine theta, depending on where the angle touches. The axis that touches the angle will get the cosine. Macam biasalah. We know this already at this point. Sekejap Let me see, ada orang baru masuk. Tak. Okay, tak ada. Okay. Okay, so we break it down. We started off with a vector. They gave us a vector. It's called V naught or U. And then we resolve it into UX and UY because we want to know what happens to the velocity in the X and also in the Y. So this guy goes up, 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 up. The displacement increases. The displacement increases, and up to a point it reaches a maximum height. So this vector, this velocity vector, has now decreased and now has become Vy equals to 0, but the Ux still becomes Ux. There is no acceleration in the x-axis, therefore the velocity does not change. Remember the equation for acceleration? Average acceleration is the change in velocity over the change in time. And change means, when you have a delta, it always means final minus initial. So V final minus V initial, T final minus T initial. We can just ignore time for now. So what I'm trying to say here is that if your V final and your V initial does not change, this would give you a 0. This would give you a 0. Therefore, your acceleration in the X is equal to 0. Or vice versa. So here we already know that the acceleration in the X is 0, therefore the velocity does not change. Or if the velocity does not change, therefore acceleration equals to 0. Okay, so that is something that you need to relate back to the initial parts of this chapter lah. Okay, and then when it reaches the maximum height, this maximum height corresponds to V equals to 0. So if you're using the V equals to U plus AT equation, this guy needs to be a 0 because we are trying to find the time taken to reach this point, which is the maximum height. When I'm solving this equation for time, I get the time over here, not at the end. This is very important. When I solve this equation and I put 0, which it corresponds to the point over here, the time that I'm trying to find it must correspond to the same place as well. If I find the displacement over here or the velocity over here, then the time that I get would be capital T, or the total duration. Okay, so there's a difference in time depending on where you select the velocity. So I hope I'm clear on that. So I hope no one is confused. Okay, kita select velocity. The velocity that we select, contohnya kat sini, kita akan dapat T kat sini. Kalau kita select velocity kat sini, kita akan dapat T dekat sini. Bukan, T does not mean here lah sebenarnya, but I imagine that this is an x-axis and it is time. So this is why I always like, time is here, but actually time is like time. Tak ada pun kedudukan. Okay. Okay, and then when we reach this point, we solve for Vx. Okay, it should be here lah sebenarnya. Tapi tak apa, untuk memudah kita nampak. So Vx and Vy. Okay, Vx is to the right, Vy is downwards. We know that this guy is a negative. This guy is a positive. The value, the value direction, sorry, the magnitude and the direction. And when the question asks you what is the vector, what is the final velocity, you have to give them a vector, which means that you have to give them the magnitude and also the direction. So you have the Vx and the Vy, you solve using the linear kinematic equation, using the table, etc., etc. Final step is to find the magnitude. Magnitude gives you Vx squared plus Vy squared square root. You will get magnitude. Do not put the plus minus. I know I tell you guys like square root has a plus minus, choose positive or negative, blah, blah, blah. I tell this all the time. But for this equation, Pythagoras theorem untuk magnitude vector, do not put in the positive, negative. It just gives you the magnitude. The direction that we are concerned about, the positive and negative too, we get it from the angle, the inverse tangent equation, sorry. So theta inverse tangent Vy over Vx, and you will get the direction from this guy. This Pythagoras theorem equation gives you magnitude. If you get like positive, negative 4, contoh V equals to 4, jangan letak negative, jangan letak positive. Just don't. Just leave it as it is, just 4. Okay. Just say, okay, the magnitude is 4. When we talk about magnitude, we're always talking about the value. We're not talking about the positive, negative. Alright. Tapi dalam linear kinematics, kena concern about positive, negative sebab kita dealing with vectors. Magnitude, kita dah hilangkan dia punya vector tu. Kita dah hilang. I mean, we're just finding the magnitude. Okay, so I hope that is clear for everyone. Okay, so now kita akan move on to another example yang slightly harder. Kita tackle symmetrical projectile motion earlier on, and we know the strategy. Use the 4 linear kinematic equations. Okay. So this is a non-symmetrical projectile motion. I don't know. I have another example before that. Okay, this one. The airplane or this one? The airplane. I think we have not done the airplane yet. Or have we done it? Belum ke dah?
Macam dah je.
Macam dah, okay. So, okay, for this problem, it says projected horizontally. That means, kalau soalan cakap macam ni, that means you don't have the uy is equal to 0. Ux equals to some value, whatever. Okay, this is what it means. Remember the keywords for the questions. Okay. Okay, so we already solved that one. This is another one, non-symmetrical projectile motion. We have, okay, Sophia said we have, okay. Non-symmetrical projectile motion thrown upward at an angle from a certain height. Okay, so kat sini previously for the previous example, we started off 100 at the top and 0 at the bottom. This was the airplane. Tidak. Okay, sorry for the distraction. Let's go to this slide kejap. Okay, so kat sini kan, I told you the airplane was moving down, right? It was moving down, and therefore our S is delta Y, um, Y final minus Y initial. And I said, okay, kalau jatuh bawah kosong kan. So Y final is 0 minus initial 100 here, 0 here. So this is a 100. This is what I told you. Okay, but this problem, it starts the 0 at the top and at the bottom is minus 45. Dia punya Y. This is Y0, this is Y minus 45. This is the X. This is the X, exist final displacement in the X lah. Okay, so if we wanted to know what is the displacement, because we need to initialize all the parameters first, right? So S equals to delta Y, Y final minus Y initial. Your Y final is minus 45. Your Y initial is 0. Okay, it's still a minus 45. But if you see this arrangement, do not be confused. Just use this equation that I told you. Just use it. It will work. Okay, it doesn't matter if this guy is a positive and this guy is a negative. Just use the final minus initial and you will get the answer. Or if you have a shortcut for that, just use your shortcut. Make sure it's correct lah. Okay, so don't be alarmed lah kalau dia tengok bawah ni, kenapa minus 45? So don't be alarmed. Okay, so let's start with this problem. So horizontal component, x-axis, vertical component, y-axis. Here they said positive is up. Okay, we already know that. Acceleration in the x is 0, acceleration in the y is minus 9.81. Initial velocity, they gave you v naught equals to 20, which means that you can resolve this into ux and uy. Sini ada angle 30 degrees, which means that you will have a component in the x and a component in the y. Kalau kita launch kita punya u macam ni, then you don't have any uy. There's no, this is not the symbol. There's no uy, only ux if it's launched horizontally. In this case, it's launched at an angle. Therefore, you can resolve it into x and y. Okay. So ni senang, tak payah buat dah kot. 20 cosine 30, whatever touches the angle gets the cosine. Whoever does not touch the angle, in this case is the y, gets the sine. Okay, straightforward. Easy at this point. So final velocity is Vx 20 cosine 30 because it's equal to the Ux. Ni pun dah patut tahu dah at this point. And then V, we need to solve it using the equation V equals to U plus AT or whatever equation that you like. Time interval, you tanya the distance X, time to reach the ground. So the time that they are asking is T over here. They're not asking dekat sini, dekat maximum height ke apa ke. No, they're asking time to reach the ground. This is the ground, this is your time. If you want to find the time here, then the velocity should correspond here. The displacement should correspond here as well. So semua kena correspond here. Okay. Velocity when touching the ground is also asking for velocity. And we know what is our Vx. We just need to find our Vy. And we already know that our h or our displacement in the y is minus 45. It's going down by 45 meter. Therefore, the displacement is a minus. Okay. Okay, so let's do this one. How do I solve this? What should I start with? I already have the h, I already have the s, I have the a, and I have the u. Okay, u, s, and a. Oh, USA. But what equation should I use to solve for V, T, and H? For V and T. Cari Vy. Okay, Sheki is saying cari Vy. Sheki, what equation are we going to use to find that?
Vy kuasa 2 bersamaan U kuasa 2 tambah 2AX.
Okay, thank you, Sheki. V squared U squared plus 2AS. V is unknown, 20 sine 30. Okay, let me zoom this so I can write. buat dalam keadaan yang sangat besar. Okay. So V squared equals to U squared plus 2AS. V is our unknown. We take this value 20 sine 30. We're solving for Y, so all the values should be Y. Then 2 minus 9.81. Value for S is minus 45. Can someone solve V for me, please? What is V? I don't know where my calculator is. T. And then I'm going to, anyone got the answer? V squared, V equals U plus 80. And then probably we can use V equal to U plus berapa?
2 darab 9.81 darab 45.
Berapa? Dapat tak? 30 minus 9.81. Come on guys, berapa ni? 9.81.
29, 29,
879.
29.38.
38, okay.
Ya,
Thank you. 29.38. Sekejap, saya buat warna lain. 29.38. Okay, so 29.38 we got from here. So we use it into our next equation. V equals to U plus 80 to solve for T. So 29.38 over here. I can solve for T. What is the T? T equals to 29.38. Banyak pula cik ni. Okay. So what do we get for the T? Divided by 20 sine 30. Divide pula tu. Yes. 20 minus 20 sine 30. Divided by 9.
darab 9.81 darab dengan negatif 45.
Berapa? Sorry. Berapa lagi sekali? Is there an error in our equation? I mean, in our values? Cuba tengok betul. Ada error tak dalam calculation kita ni?
Miss, nak tanya, Miss pula, doktor.
Ya.
Kalau dia punya decimal place dia tu, dia tak sama, dia tak apa ke?
Awak bundakan dekat akhir ke dekat tengah-tengah tu?
Sebab kalau saya dapat 29.63.
Okay.
Tapi dekat chat dapat banyak yang lain. So saya tak tahulah.
Okay. Awak bundakan dekat mana? Awak 20 sin 30 ni awak kira, lepas tu letak tu decimal places, lepas tu baru kira yang lain Macam tu ke? Kau pakai radian?
Saya masukkan semua sekali.
Kau masukkan semua sekali patut sama. Sekejap.
Doktor.
Yep.
Yang 20 sin 30 tu tak kuasa 2.
Ya, yang ni tertinggal kuasa. Tertinggal kuasa tak?
Tak apa, saya kira lagi sekali.
Okay. So kita pakai majority punya answer Thank you untuk semua yang tolong walaupun tersilap sikit. It's okay. So our V is 31.35 here mengikut majority. Saya tak tahu, saya tak kira. What should the sign be? Is it positive or negative? Saya rasa setiap kali kelas yang saya tanya sign dia apa, tak ada lagi yang terus bagi tahu saya, okay, jawapan dia negative 31.35. Tak ada. So korang kena ingat tahu benda ni, saya takut pula. Saya tak ada tahu untuk tanya waktu exam. Ingat sendiri. Negatif turun bawah. It's going down. Minus. Okay, so here it becomes 31.35. So I don't know what the answer is. Let's calculate this together. Minus 20 sine 30 divided by minus 9.81. Dapat 4.62. Okay. Seconds. Betul tak? Ada tak orang lain dapat lain daripada saya? Okay, if you did not put the negative because it's falling down, yes, correct. If you did not put the negative, then your time would be negative when you solve for this equation. Kalau kita positif, saya rasa lah, sekejap, kita tak tahu. Positive 31.35 minus 20 sine 30 and then divide by minus 9.81. Yeah, you would get a time that is negative. So bila dapat time negative tu confirm salah. So please go back to your equation. Okay, where am I missing the signs? Mesti ada missing. Ataupun salah tekan calculator ke. So please go back if you get your negative time. Sebab salah, confirm. Okay, time is always positive. Alright, so we solve for that. Quite easy, right? The distance. Now we solve for the distance x. Time to reach the ground, we found it. Velocity when touching the ground, we found it as well. So the time that we got from the y side is equal to the x side. Sama. Sebab basically it's the same point. Sama lah time dia. So how do I find the displacement? What equation do we want to use this time? S equals to u 1 over 2 u plus v t. Boleh ke? Boleh. Let's use that. S equals to 1 over 2 u plus v times t. Kecil tulisan saya. Bangga sekejap tengok. S equals to 1 over 2. Sekejap. Kita padam balik sebab tak cukup tempat. Besar balik. S equals to 1 over 2 u plus v times t. So the time that I should use in my equation should correspond to the time that for the total duration yang kita dapat dekat hujung projectile motion. So this guy is basically 2u cancel out. So I just have to multiply u with t, u 20 cosine 30, and the time is 4.62. Okay, so whatever that is your range. 20 cosine 30 times with 4.62. So I get 80 meters. Hopefully that's right. Okay, so that is the distance x. So this distance x, therefore your final coordinate when the ball falls down, I think it's a ball. When the ball falls down the coordinate is 80 minus 45. Tapi dia tak tanya pun coordinate. Kalau tanya, what is the final coordinate of this object? 80 minus 45. But they are asking the distance x kan? So just give the distance is 80 meter. Do not forget units. Time to reach the ground, 4.62 seconds. Velocity when touching the ground. Oh, kita tak solve lagi. So kita kena buat equation Pythagoras theorem lagi. So V equals to magnitude V equals to Vx. What is that? 20 cosine 30 squared plus with the Vy, which is minus 31.35 squared. Okay, and then theta is equal to inverse tangent of minus 31.35 over 20 cosine 30. Okay, so that is your answer lah, whatever that answer is. Again, velocity Pythagoras theorem equation ni gives you magnitude. Do not put in positive, negative, do not. Just the magnitude that we want to know. And then the angle. Okay, let's do the angle because ada negative kat sini kan. So minus 31.35 divided by 20 cosine 30. And then inverse tangent of that, I get minus 61. So I get minus 61. Did anyone calculate for the magnitude? minus 61 degrees. Dapat jawapan tak? What's the answer? Kita perlukan kerjasama dalam kelas ni untuk kira-kira sebab saya tak, sebab saya malas. Okay, what's the magnitude? Please give me the answer. 20 cosine 30. Okay, we have check here. 16.39. Okay, Syaki said dia silap sebab dia tak letak kuasa 2. Okay, noted. 16.39. That is the magnitude. Okay, so the velocity when touching the ground is 16.39 meter per second. Velocity, right? Ada meter per second. At minus 31 degrees or 61 degrees below the x-axis. Okay, what does it mean? It means that, mana gambar tadi? Kita buang sekejap gambar-gambar ni semua. Kenapa ada benda alam? Buang sekejap. So this is the velocity vector. So if I resolve it, it should be like this, right? Vx, y. This is the, yep.
Untuk vektor tu, kita orang dapat 35.82.
This one, magnitude,
Magnitude.
31.82
35.82.
or 35. Thank you. 35.82. Okay, kena double check lah yang tersilap tu kan. It's okay. Mistakes happen in class. Dalam exam jangan buat mistake. So if you want to imagine how it looks like, the final velocity should be pointing in the direction of the projectile motion. This is your Vx and this is your Vy, and the angle is with respect to the x-axis, and it is 61 degrees. Okay, that is how you look at it. Okay, so I hope it makes sense for everyone at this point. Ada soalan tak pasal soalan ni? Tertinggal kuasa 2. Okay. Doctor, for the time. Kenapa Ian? I think it's 4.22. 4.22. Oh, saya salah kira ke? Let's see. Ini negatif kan? Minus 31.35 tolak 20 sin 30. Saya tak cosine tadi. Divided by minus 9.81. 4.22. Oh betul. 4.22. Saya silap kira. 4.22 Thank you. 4.22. Okay. Okay, so I think we already solved this one. It looks like it's slightly harder, but sebenarnya sama je. The approach is exactly the same, but this time they did not ask you for the maximum height. If they ask you for the maximum height, use the same approach, v equals to 0. It still applies here. Okay, next one. Throw at a downward angle. Throw downward at an angle from a certain height. Okay, so sama dia punya displacement. Coordinate pun sama. It's minus 45. So this is it. Oh, it's the same guy, I think. Dia ada masalah. Dia patah hati. Okay, so he's like throwing things off a building. Mula-mula ada angle. Lepas tu dia penat kot, tangan dia penat. So dia ke bawah. Okay. So it's the same guy. So now the velocity vector is 30 degrees below the x-axis. This is your V0. How do we resolve this into its x and y components? So if I were to draw it, to draw the components over here. Okay, kita tengok So this would be my ux and this would be my uy. Okay, it looks straightforward, right? Ni vector yang dia throw, this is the velocity vector in which he is throwing the hadiah x dia. Tak tahu. Zaman sekarang ramai orang patah hati. So V naught, kita nak resolve into the X and Y components, and the X is touching the angle. So tak ada masalah kat sini. So UX is simply V naught cosine 30. And VUY is V naught sine 30. So dia tak ada, there's no trick here. Dia memang sentuh dengan X-axis. So you don't have to flip the cosine and the sines. Okay, so that is easy. So acceleration is 0 in the X and acceleration is minus 9.81 in the Y. We know this already. This guy is, you would get a negative. Oh, this one, forgot to mention. Kita buat below X-axis kan. Ada hazard sikit lah kalau kita buat below X-axis. Okay, this is the trick here, I forgot. Okay, so you started off with a vector here. It's going down in the Y. And it's going down in, sorry, it's going to the right in the X, right? Oops, excuse me. So your Vy is actually going down, but I said it's just V naught sine theta, which is incorrect. Yang sebenar-benarnya is you should have this minus 30, or you can say Uy is equal to minus V naught sine 30. Oh, I'm having trouble writing pula. Dah pakai orange, or this is a bad color. Okay, so 30 Uy is equal to minus V naught sine 30, or Vy equals to V naught sine minus 30 degrees. It's below the x-axis. Remember, angles below the x-axis is a negative. So UX, the trick is in the Y. So this is something to take note of. If your angle is below the x-axis, put in the signs beforehand, like this guy, like me, or you put in the negative 30. Nak selamat negative 30 lah. Selalu ingat, below x-axis ada negative sign dekat angle. Okay, so it has a negative here. Okay, so that is the trick to this question. Final velocity sama je, V equals to U plus AT, time interval, we can find it, displacement X. Basically, the rest should be straightforward lah. Let me just do it quickly. V equals to U plus AT. Okay, so we want to know what is the V, but we don't know what is the time, so we just leave it like this first. V squared equals to U squared plus 2AS. We have the distance. We have the U, 20 sine 30. It's a minus, but it's squared, so it doesn't really matter anyway. 9.81 and minus 45. You would get the V as something. The V would be negative sign. Whatever the V is, plug it into this guy and you solve for the T. And then sama juga for the displacement, it's S equals to UT plus 1 over 2 AT squared. This guy becomes a 0. It's just UT. So 20 cosine 30 times with the time that we got from here. We got the T as something and we got the V as something. Okay, so sama je. It's the same steps except that we had to know that this guy, when we resolve it, it's a negative. That's the difference. Yang lain semua sama. Okay. So now I think we are ready to solve some questions. I mean, you are ready to solve on your own. Let's do one. Example 2.6. An artillery rocket is fired with an initial velocity. What is an artillery rocket? I don't know. But gambar dikasih tu macam kereta kebal kan. So bayangkan kereta kebal lah. I don't know. I really don't know what it is. Oh, kereta kebal dia punya tayar macam ni Whatever. Macam tu. Okay. It's fired with an initial velocity of 300. 300. V naught is 300 meter per second at 55.0 above the horizontal. So the launching angle is 55 degrees. It explodes on a mountainside 42 seconds after firing. So T capital T is 42 seconds. This is when it reaches the mountainside. My mountain is like super bullet, sorry. Okay, the time to reach this point, point X, T equals to 42 seconds. Projectile motion macam tak? Macam, dia tak saya lukis balik. It's just looks off. Okay, kita cuba kita cuba dengan bersemangat, penuh daya dan jitu. Okay, so the time taken to reach this mountainside is 42 seconds. And the angle for it to launch, 5. This guy is our vector V0, 300 meters per second. Okay, so we have this guy, which is the maximum height. We have this guy, which is 42 seconds to reach the mountainside. This is the landing point lah, landing point or the total duration. Landing point. Okay. Determine both the horizontal and vertical displacement. Is asking for x, sx, and sy relative to its firing point. So it's saying that this guy punya coordinate is 0, 0. This is what it's saying. What is its velocity when it hits the mountainside? So again, you need to find the vx and the vy, and then find the v and the theta. Okay, you have the t, you don't know what the height is. You have the v0, the v0 is yours, which means that you have the ux and the uy. You have the a, you have the a in the x and the a in the y. Apa lagi? V0 is 355 degrees. A is 0 and 0 in the x and 9.81 in the minus 9.81 in the y. Sorry. AX is 0, AY is minus 9.81. Okay, so I'm going to give you guys 7 minutes to do this. Try to do it in a table. Saya akan panggil like random people to solve for UX, what is UI, what is VY, what is VX, stuff like that. Okay. So 7 minutes from now is 8:40. So 8:47. Let's do this. Okay. Hopefully you guys can solve it. Try your best. It will really test whether you understand projectile motions or not, because it's slightly different, right? Ada soalan boleh tanya. Okay, so let me look at the chat. Cuma kita kebal. Sorry for the kita kebal. Buat jangan tak rajin. Saya letak nama dekat dalam. So saya nak suruh Munira and BX sama je. Amy lah. Amy, Y, Lutfi, siapa yang tak pernah panggil lah. Amirul Faiz. Amirul Faiz ada VY. Okay. And then for the time, siapa Muhammad. Tak nampak. Oops. Participants. Oh, Ayub. Okay. Ayub. Okay. And then Afika, Shafika. Okay, nak tengok je approach charity macam mana. Tahu jawapan dia akan sama. Buat tengok cara korang buat macam mana. Berbeza ke sama? And then can we get... Siapa yang sekarang panggil lah? Fikir jap. Elisa. Saya rasa saya tak pernah panggil. Elisa untuk SX. And for the guy, can I get Arman? Arman eh? Okay. Alright. Semua ada ke? Ada tak yang tak ada? Munira ada tak? Munira dah ready ke? Ada. Okay. Alright. So Munira awak nak pakai mic ke nak tulis equation? 300 cosine 55. Okay. 300 cosine 55. Okay, Amy, what's the VX? Amy cakap kacang je ni.
Sama je.
Sama je. Okay, thank you. Lutfi, what's the VY? UI, sorry. UI.
300 sin 55.
Okay, thank you. Amirul Faiz, how do you find the VY?
Sekejap, tengah buat.
Okay. Afika Syafika ready dah untuk time?
Belum doktor, kejap.
Okay, Ayub ready tak untuk time?
Dah.
Dah, okay. So Ayub buat macam mana? Sekejap kita besarkan. Okay.
Saya buat equation pertama. V sama dengan U tambah AT.
Okay. Tapi awak kena solve for VY dulu lah kan? Okay. So awak buat macam mana VY?
VY saya dapat kosong.
VY dapat kosong. Oh, okay. Kejap. Kita dah tahu time ke belum?
Time nak cari kan?
Okay, tapi soalan kita dah tahu ke belum? Kuatnya macam tu. Kapal terbang. Bukan dah ke? Ayub, kita dah tahu time tau.
Oh.
Okay. So, macam mana awak dapat kosong tu? Muskilnya saya.
Okay.
Okay. So, kita dah tahu time. So, kita patutnya pakai je dalam VY ni. Okay, so tak apa. So, kita discovered that sebenarnya doktor nak boleh trick soalan. Okay, so T is equal to 42 je. Tak ada equation apa pun. Okay, so Arman, SY tahu tak? Have you done it? Patutnya ni lagi straightforward dari projectile motion yang symmetrical lah. Sebab dia dah kasih time. Time tu is like the big component. Arman?
Doktor.
Yep.
Saya guna equation V kuasa 2 sama dengan U kuasa 2 tambah 2AS.
Oh, okay, boleh? Sekejap. V kuasa 2 U kuasa 2 plus 2AS. Okay, V ni awak letak as apa?
V tu saya letak VY. Saya dapat negatif 166.27.
Okay, 166.27.
Point 27.
Okay. So 166.27 minus square lepas U 300 sin 55 and then
Lepas tu tambah 2 AS, A tu negatif 9.81 dan S tu nak carilah. Jadi saya dapat jumlah besar, doktor. Saya dapat 1668.97.
okay 97. Okay, tak apa nanti kita betul tak? Saya tak tahu. Kita tengok. Okay.
Terima kasih, doktor.
Okay, thank you. Very good. Siapa tadi? Lutfi dah jawab. Siapa yang lepas Lutfi kat sini? BY.
Saya.
Siapa
Amirul Faiz.
Amirul Faiz. Okay. Okay. Macam mana cari?
VY sama dengan 300 sin 55
Okay.
tambah negatif 9.8 darab 4.2.
4.2 ke 42?
42.
42 42. Okay.
Sama dengan negatif 1.66.27.
1.66.
166.27.
Okay. Okay. Awak ni ada tendensi salah decimal places ni. take note nanti jangan buat salah dalam exam. Minus 166.27 meter per second. Okay. Okay. So dapat sama dengan Arman tadi. Okay. So Arman dapat jawapan yang jumlah yang besar dia cakap. So let's see betul ke tak. Saya pun tak tahu jumlah ni besar ke betul. Ada tak orang yang dapat sama dengan Arman? Tak apalah nanti kita buat. Sama Okay, so memang jumlah yang besar. Saya sukalah perkataan Arman jumlah besar tu. Okay, SX Elisa. Betul Elisa, saya tak lupa kau. Oh, belum siap ke belum jawab? Okay, Afika Syafika, what's the time in the X direction? Aduh. Afika
Kosong ke?
Time.
Kosong ke? Tak.
Time in the axis. Jawapan awak kosong ke? Macam mana awak kira?
Guna V equal to U tambah 80.
V equals to U plus 80. Okay. V equals to U plus 80. Okay. Kita cuba. V equals to U plus 80. Okay. So awak substitute U as 300 cosine 55. Kan? A awak apa?
A negatif 9.81.
Okay. So kat situ saya nampak
9.81 patutnya.
Bukan. X, dia punya AX is kosong. Kan? Dia tak ada gravity dalam X axis. Gravity hanya acting dekat dalam Y. Pukul berapa dah ni? Okay, kita ada 4 minit. So kosong So jadi kosong. So V is equal to U. So macam mana awak cari time tu? Okay, sebenarnya time dalam X axis sama dengan Y axis. Dia tak ada perbezaan. What was that? Dia tak ada perbezaan Kalau saya cakap time dekat Y is 42, dekat X axis pun 42. Okay. Saya tanya sebab saya nak tahu korang faham ke tak. Okay, take note on that.
Okay.
Alright. Bukan saya nak bukan saya nak perli ke apa. Saya betul-betul nak tahu korang faham ke tak. Okay, so I hope no one terasa dengan saya tahu. Okay, SX. Elisa dah ke? Elisa belum? Okay, belum ada jawapan. Dia tengah panik kot. Okay, kalau siapa nak tolong Elisa tak? Sebab kita nak kehabisan masa dah ni. Doktor, saya rasa saya tak dapat. Okay, Alisa pakai equation apa? Siapa punya yang ada ayam tu bestnya? Doktor, kenapa S dia tak sama? S apa yang tak sama? Pakai mic. Kita nak habis masa dah ni.
Yang kan 1668.97 tu kan, kenapa dia tak sama je dengan yang X?
Okay, so displacement ada komponen S dengan komponen Y dengan X kan? Time yang tak ada, time yang sama. So, bila kita cakap pasal S ni, kita cakap pasal SY.
Oh, faham.
Tapi kat sini pun ada, okay, kita tak tahu lagi. So Sx is ut, Elisa tuliskan Sx equals to ut plus 1/2 AT squared. Okay, so what did you substitute into your equation? Elisa tak boleh pakai mic ke? Okay, I think Elisa tak boleh pakai mic. Faham ke kenapa S kita tak sama? Faham ke? Bila kita landing, kita launch kan? Kita launch our whatever, peluru, I don't know lah dia launch apa sebenarnya. Dia launch peluru, lepas tu jatuh kat sini kan? Bila dia jatuh, kita ada daripada reference point, contohlah mountainside ni lagi tinggi daripada kereta kebal. Kereta kebal tu kat bawah sebenarnya, tapi saya tak tahu nak lukis macam mana sebab saya tak tahu dia punya displacement kan. So let's say this is the distance between kereta kebal and the landing point. So this is your Sx. And then dia ke atas by this much, which is 166. Saya tak tahu tadi dapat berapa. 1668.97. Sebenarnya sangat tinggi. Tapi gambar ni dia tak represent correctly sebab saya tak tahu value dia kan. Tapi kalau kita nak lukis betul-betul lah pakai 166.8 ni, dia akan jadi kereta kebal kat sini. Okay. Korang terima je lah kereta kebal saya ni Okay, lepas tu dia naik atas. Mountain tu tinggi gila. And sini kosong kan? Ni kosong. With respect to the reference point, this is your XX, SX, and this is your SY. So you akan dapat 1668.9. SX akan dapat something else lah. Dia tak boleh sama displacement in the X and in the Y. It shouldn't be the same. They are different quantities. Okay, so Elisa macam mana? Apa conclusion kita dah pukul 9 ni? Oh, faham. Okay, so Elisa dia tak dapat selesaikan sampai habis. So saya tolonglah. A is kosong. U kita adalah 300 cosine 55. What is the time that we should put here? 42. So akan terus dapat Sx kita. So 300 cosine 55 times 42 seconds is 7227. Harapnya saya betul lah. 7227.06 meter. Okay, ada satu lagi benda yang kurang tepat kat sini. Kita punya SY ni dia ke atas ke, dia ke bawah ke kiri ke kanan ke macam mana? Sign kita betul tak? Sign kita betul ke salah? Jawapannya betul
Betul.
Jawapannya betul. Di atas bukit. Positif.
Sudah atas.
Apa? Sebab dia ni atas.
Di atas.
Okay. Okay, bye everyone. Korang di kelas kan? Okay, bye-bye. Dah habis masa dah. Bye korang. Thank you.
Thank you, Doktor.
Okay,
Thank you, Doktor.
take care.
Thank you, Doktor.
Have a nice day, Doktor.
Have a nice day.
Doktor. Assalamualaikum.
Salam. Bye.